In this video, I introduce a conservative policy iteration for policy optimization. Conservative policy iteration is a reinforcement learning algorithm that prevents performance drops by taking small incremental steps towards a new policy rather than fully committing to a greedy update. A Markov decision process is defined as a tuple S, A, P, C, rho 0 and gamma, where S is a set of states, A is a set of actions, P is a transition probability distribution, C is a cost function. Rho 0 is the initial state distribution, and gamma is a discount factor. The expected discounted cost of a stochastic policy pi is defined as here, where A pi is the advantage function as shown here. A, Q, and V are explained in this figure. When A pi larger than 0, taking action better than the baseline, otherwise worse than the baseline. The expected cost of a opposite policy pi tilde is expressed in terms of the advantage A pi over pi, as shown here, where rho pi tilde is discounted visitation frequencies. If summation over A greater or equal to 0 at every state S, the policy update pi tends to pi tilde is guaranteed to increase the policy performance rho. A local approximation of expected discounted cost is defined as here, where the discounted state visitation frequency rho pi tilde is replaced by rho pi to ignore changes in state visitation density due to changes in the policy. If a greedy policy pi tilde is computed and the current policy is used as the old policy, the new policy is computed via a stochastic mixture as shown here, where alpha is the distance between pi and pi tilde. By keeping alpha small, conservative policy iteration updates ensures that the expected cost of policy pi new doesn't decrease. The difference between pi and pi tilde is defined as dTV max, as shown here, where dTV is equal to this formulation if alpha is calculated by using dTV max and epsilon calculated by the expectation of A pi. The lower band is defined as here. Using equation here leads to the following lower band. The right side is a surrogate function. CPI method directly maximizes the surrogate function, which is guaranteed to generate a sequence of monotonically improving policies. Here is the pseudocode of CPI method and explained in this figure. For more details, please check with these references. Thank you. Bye.